Right, well, good evening everybody, goedenavond. And Graham and I both remember seeing in the, I suppose it would have been early 70s.
In our youth, yes.
Presentations by Doug Charman and other people who used to do what they called the aerial circus. Doug Charman, G6C, J, lived around here for some time. And he used to do it at 10 gigs with a klystron oscillator. Now, we had to do a talk on antennas, didn't we, for the Bracknell Club initially. And we were also asked to do something on antennas at the Burnham Beaches Amateur Radio Club as well, near Slough. Yeah, so we thought, what the heck are we going to do? And then we remembered these demonstrations. We thought, well, we can't do it at 10 gigs, haven't got anything that would go that high, at least not sensibly. So, but we can do it at 1296 because we've got the TS2000X. So what we're going to do, I'm going to try to show you a number of antennas at that end. There's a detector this end, and we're going to try various antennas. There's some helicals over there, which are one right hand, one left hand. So we'll show you the difference in that and how they couple and don't. And there's also a cubical quad there as well. And we've got a couple of other antennas which we can't demonstrate, but we'll show you a bit about it. Right. Right. So if I think I probably need to be around that side so I can see the meter. If you can't see the meter very well, try and get in a place where you can. But I do have this thing here, like what I knocked up.
This is just a diode detector off the dipole.
Yeah.
Into the meter, which is quite sensitive. Yeah. Triplet.
Right. Now, let's have the you can see as we get our RF. I'm in the right mode.
You're on 1297.
Yeah,
exactly.
Transmitting. So I need a bit more on then. How many watts have we got? Power.
When you get one of these rigs, you spend about a month trying to work out what all the buttons do.
The power meter is reading something.
Oh, good, right, okay. Yeah. Right, well, you can see what I've got here, you can't see, is a simple dipole connected to a detector.
I shut this out, didn't I?
It's all right. And that goes to this detector here and just goes to the meter. And it goes to this thing that the picture will go up and down with the voltage if we get enough signal.
How do you turn it back up?
I'll have to see what mode you put it in. Anyway, I've got more coupling than this if you want it to go. I'll come round.
Should do, that's what I
Yeah. It's different every time we do this. Meters off.
Yeah, you got something on the meter.
Anyway, what I will show you now. This is doing 1296. On 702. Right. Now, this is a simple detector, which I can see. Sorry, that's the transmitter. And that's what will happen. So I'll use this as the detector. Bring it to here. Can you work the PTT? Right. Now, so we've got here straightforward diode, dipole, and a straightforward dipole here. Now you can see here that it's working, coupling quite well that way, but as we come round to the opposite polarization, pretty much all the signal goes. Okay. And but we can also show you that it's pretty much the same. Off the top here, we're getting the reflection of the bottom there.
Sir, could you move yourself around the other side of the table? And
I would like to, well, yes, I suppose I could, but I can't do that and see the meter at the same time.
I can read the meter out if you want some numbers.
Okay. Some of you see, I can listen to the bottom. Right, so you can see it's pretty much the same all the way round there. But again, if we go cross-polarised, we get nothing. So I'm going to put this back in here. Can you move your vehicle? Are you transmitting?
Do you want me to? Yes, please.
But you all know about Yagis, near the Yagi. What we can show you really is that now the principle of the Yagi is that as the dipole goes beyond a half wavelength long, it becomes inductive, and shorter than half wavelengths, it's capacitive. Now that means that any RF going this way, if you get these inductive enough, you will get a phase shift, which will then go back in time so that it phases up with the dipole. That will give you some gain. So let's show that, please, Ray. So you can see we get quite a lot of extra gain by putting that in. Now we also can put in the director, same principle, but of course the opposite way around. So if I put that in, I think we're having problems with reflections up and down here. Might have to do some. I think it's got reflections off here and things at the moment. But what you find is that actually with the reflector you will get more extra gain using the reflector than the director.
Okay. There it is, yeah.
Now, the other thing that you'd find is that there's no point doing extra reflectors, because if you put more reflectors on, what's behind it is being screened by that one anyway.
Yeah.
So it doesn't do you any good. We'll try and come around here a bit. And so that's so that's the principle of that. No, but again, that's the sort of simplest case. So it way round the right here. Yes, we're getting the reflector there coming in there. Okay. Yeah. director, yeah. So, right. So I'll turn that off for a minute while we're reconfiguring it for different aerials. That's about the simplest as you get, those aerials. Or antennas, whichever you like.
Quite surprised the difference that the reflector and the director make.
Yes.
You know, you would imagine it wouldn't make a lot of difference.
No, yeah. Yeah, and of course you can stack the directors up, but you can't stack up the reflectors. So, we're now going to, this is a standard cubical quad now.
It's on the other side.
Yeah, I think so. Yeah, I think that'd be a lot better. Oh, sorry, no. No, I'll straighten it all up now. Right. That can go anywhere, can't it? So,
Let's put these stuff in the way.
yeah. We'll do that. Yeah, you can see from this lot that we are both big fans of W.E. Robinson.
Well, he was a good guy, wasn't he?
I need to get round, I think. Whoops. Right, now, okay. Now that's a cubical quad that's what it is, it's two half waves bent round and stuck together, roughly. So let's show you what happens with this.
The uncertain musical boxer.
Yeah. Very true, there we go. So again, I'm working, got some gain there horizontally, but actually if you can see the meter, it's probably not going down quite to zero on the meter because there's a little bit of radiation off these vertical bits. And you can sort of doesn't matter where we are there. So,
It was the dipole. You could run the receiver all the way around, and it was even strength all the way around. This wouldn't be that he knows off it.
but similarly to similarly to the Yagi, be right tonight. I know what I'll do. I'll put it that side. Right, that's better. Right. So similarly to a Yagi, you can have a reflector and a director. What's all this on these? Which one's I think that's the
big one.
Reflector. So we can put the reflector behind there. Again, you can get some gain. I can't easily show the. I suppose if I can bend it, I can. So you get the extra gain with the director, but again, you can hear it's not as big a gain with the just
the
one.
First one gave you about 50%, that one's giving you about 35.
Yeah, that's probably right. If I make it into a proper dipole, I think that's roughly the right spacing. I can you can see we've got quite a lot on there. Right. What else would we show? So that's giving you a cubical quad.
The directivity reflectivity of it? If you go around it with the receiver, or no, with the receiver?
Yes, yes, I will, yes.
Okay, yeah.
Okay. So you're not getting much, that's the front to back ratio.
Well, there's a lot on there.
It makes a lot of difference.
I
You can see how crudely these things are made, how, you know, it's, you don't have to be quite as precise as you might think sometimes, even at this frequency. It's more difficult when you get to 10 gigs. It's, let's give you the thing of this. Right, so you get there, you don't get so much off the top there, and you get as much similar about there. If I can stop it shaking around, it's like it's vibrating. So that's a quad being exactly the same as this. But just to show you something else, I can actually also go back to this. And I can show you with this again. I can get some gain even with the reflector and the dipole and the reflector. So that's something to play with.
It also goes to show how much effect sort of random elements around the place that might be something else can upset it, isn't it?
Oh yes, we're getting all sorts of reflections.
If you could do that with just what we wouldn't ever consider to be the right thing, then it sort of works pretty well.
Yeah.
We tried this in his shack when we first did it.
Oh,
And we couldn't get anything to work.
No.
Couldn't work out what on earth was going on. It was just all the rest of the metal work in the shack. All sorts of assorted bits of God knows what, you know.
Yeah.
We moved to my dining table and it worked a lot better.
So you laid the table with the cups and saucers and knives and forks?
Well, the level of water in it going up and down would affect it. But all right, so those are the two fairly simple ones. Now we might need a volunteer for the next bit. So just a minute, we're going to need to reconfigure because what we've got here. No, before we we'll. Now what we've got here are two antennas, or helical antennas. Now, as you can see, this one is spiralling round that way, and again, it's it gets this thin wire gets bent very easily, but it still does seem to work. And it gives you circular polarization off the end, which I shall show you. Also, you it's pretty wide band because it's a travelling wave structure, and they're pretty wide band, much more so than a Yagi. And the feed impedance depends on the dimensions a bit. It's about 140 ohms, not 50 or 75. So.
Is that true for every helical antenna?
No, I don't think so. It depends on the dimensions of them, the pitch and thing. You have to have the pitch right, because what you've got to do is that when the signal's coming down here, it's got to go around this wire and then be in phase again there with the next by the time it's moved that far down there. So the pitch is quite significant. You see we've got little black marks on here. I'll give you other pictures. This is straight out the VHF manual, by the way. And it doesn't seem to matter much how many more turns you put on. You just get more and more gain. And so that's is there. Now for this, I'm really going to need this because those clampy things, oops, aren't strong enough to do the job. So when we're going to do it down there somewhere. Yeah, so
Do you want to put it on 2 or 3 chairs to get it higher, do you think? Or
might do, yeah.
that would get you clear of the table structure as well.
Yeah.
We've got plenty.
There's another empty box over there as well. But of course, being circular, it doesn't matter which attitude you put this thing in, except this being a bit crudely made, there is a little bit of polarisation to it, a bit of elliptical. I think actually I can probably come around and do it here. Okay, let's see. Detector. So yeah. I'll do that on there. No. Oh, you need the
But we're transmitting off this.
oh, we are, aren't we? Oops. In that case, I'll turn that off again. Right. If you want to see how this is done properly, G6CJ's presentation, I think it's on the ICB website. Right. What's on the other end of that? Yeah. That'll work if it was long enough. Should be. Oh.
Incidentally, at this frequency, this stuff is more like an attenuator than a
Yeah.
guys.
I won't beam this at you, for ignorant reasons, but I'll turn it around the other side in a minute. Because it does have a relatively good gain, this. So let's that way I'll do the detector.
Is that it there?
Yes, it is. Thank you. Right. We transmitting? Yeah.
We are now.
So as you can see, as I move it around, there's very little difference. But because it says it's rather crudely made, so there will be a little bit of difference. Now, so now let's reconfigure this for the other one. You can see this one made exactly the same, except that the spiral goes around the other way. No, I won't. Yeah, so what we'll do, turn that horrible noise off while we're doing, is to put the detector on this now. I might need right, so put your thing back on. Now you can see now there there's very little coupling because one's circular and one's there's a little bit when you get close, but not really. Right, so but no. Another thing now. Okay, go ahead. Where's the reflector? Now, what you find is, I hope this is going to work because it's. In fact, I might need a. Could I ask for a volunteer? Hold that vertical as you can. Now, when a right hand circularly polarised, which is that one. Well, let's start with the left hand. Left hand hits that. It will actually become right hand going back.
Reflection.
Yeah, the reflected one is in the opposite screw sense to the going in. This sometimes works. So I'd come around. Shall I do the? I think we both might need both of us, mightn't we? Hopefully, right. Okay. Some got any power?
Yeah, no.
Oh, right. Oh. Okay.
It's showing some signal on the meter.
It is.
Yeah.
You have to have them both hitting the same spot on the reflector. Could you bring the reflector a little closer, please? So we're now getting significantly more coupling there. So
Can you invert that?
invert what?
This way.
Oh, that one. Oh, you mean the same way round? Yeah. That's better, isn't it? Oh, yes, that's better. And if you take that away, you can see it's not the proximity of the antennas.
Okay.
So that's the moon, yeah.
That's where I was going wrong.
Well, actually, most moon banks people don't use polarisation because there are all sorts of other effects. The moon Faraday rotation and all sorts of things that being taken
And
into.
there's not much tinfoil on the moon.
Not a lot. But when you get to 10 gigs, you both have to decide which bit of the moon you're going to point at. You know, it's getting that sort of critical, particularly with something like the setup they've got at FRAS, Flight Refueling Anti-Radio. They've got a very big dish there. And there's also a 10 gig beacon in Germany that tracks the moon. And last time we were down there, they were getting a rock crushing signal from there, wasn't it?
Yes.
From it. So
And I think they've been improving it since.
yeah.
Are you saying that they transmit at the moon all the time, so you can look at the reflection like a beacon?
The beacon transmits at the moon all the time and tracks it as it goes across the sky, so it's always pointing at the moon. When it's up.
Exactly. It's a bit tricky sometimes.
But, so that's that. We're getting on pretty well with this, aren't we? What do we want to do next? Yeah, got another antenna here which I've used professionally quite a bit.
What power have you got coming out of there at the moment?
A few watts. It's 10 watts max, so
Yeah, it's FM, yeah.
it's on there. It's a set to FM. One of the things that helps with the burp is the amount of time in transmitting and things like that. And G4DSC seems to think it's all right, so that's good enough for him. Yeah, just working out
This is your mobile aerial. He's
yeah,
going to demonstrate
yeah. This is an aerial that's used in quite a few forms actually. It's a broadband antenna. You get at least 2 to 1 frequency range out of it. This is actually cut for 1297. And at lower frequencies you often find that this is either grid of wires or and these are wires coming down as well. The angle of these coming down does affect impedance and things like that, but and they can be just wires. In theory, it's a complete cone, which is why this is called a disc cone. Funny that, isn't it? And so let's show you some of the properties of this. You've got to. That's that one. That's the transmit end, isn't it? Yeah. Put that on there. And I'll click that. Good evening. Oh, silly poo. I think it will still work. That's just solder joints.
Cheap Chinese lead-free solder.
And also a not very good soldering iron when I made these. Oh yes, that will work. Right. Let me put this again. And that. And the detector.
There it is.
Oh yeah. Thanks. Thanks very much.
You couldn't say it's behind the board.
Can you come along the next time?
Yes. I could be your stooge.
Right, so let's put this on again. Okay.
Right.
You see, it's vertically polarised. It is vertically polarised, and you lose the signal when you go horizontal. So it's a wideband, vertically polarised omnidirectional antenna. So it's often, these things are often used for things like the military, where the low band can be 20 megs to 90 almost, and things like that. So if you want an omnidirectional, then that's the way to do it.
There used to be a thing around sort of 20 years ago with aluminium bits and stuff hanging down called the disc cone that was I haven't seen lately.
Yes.
On the top of my caravan, there is a receiving area for my TV, which bears a resemblance to that, apart from the fact it's wrapped in plastic.
Yeah, I would think that that's probably good because
It's called a status aerial, and it is basically a flat disc with a small dipole sticking out the top, which I can see
this would only work for vertical polarisation, and a lot
I'm
of
not
TV
sure what the
is-
television stations are broadcast from, but
Mostly horizontal, aren't they?
sorry.
Mostly
Well,
horizontal.
this status has a sort of a vertical element to it,
Yeah.
but then it has a flat disc underneath it, and I'm wondering whether it's using that technology
Well, that's
as
a
a
Yeah,
receiving area.
It's going to be based on it, isn't it?
ground plane, yeah.
Yeah. But this technique you can only do it vertical polarisation, which is why a lot of miniature stuff is vertical polarisation. Is anyway with handhelds and things. You get vertical polarisation, and the wideband characteristics are very good. I have made them out of wire as well. Things.
So what's the cardioid pattern of that aerial if you take a sideways view of it?
Right, okay, let's show you. Right, so if I...
Turn the beeper on time transfer.
Oh, yeah. Ooh, ooh, it's a glass of wine. So if I go around there, you lose the polarization. And if you go in here, then it doesn't really transmit off the top at all. Okay.
So is it a fairly sharp cut-off if you were to draw the diagram? Would there be a definite...
I think, well, let's have a go, shall we? Try and keep it. Oh yeah, there is a bit. Nice, okay. Nice. Well, there's the antennas which we wanted to show you. I do have some more antennas here that I've made, again, following the W. Heath Robinson antenna manual. I don't know, we might be able to demonstrate. What how are we doing for time?
Nothing on until next Wednesday.
It's just where we are. We have to be out by 10 sharp.
I've got the key to the door anyway.
Feeder.
Now this is a quadrifilar antenna cut for 70 cents. Now quadrifilar antenna, it's fed here. Not long made this, so it need a bit more work there. And the feed is fed up to these wires and up this coax in a particular way. And then there's another set of linkings in there. Now this inner loop spiral here is actually smaller than this outer spiral. Okay, and it has some very interesting properties. The main one of which is that it gives you circular polarization all the way around in 180 degrees. It is weird, but I have worked through satellites with it. 70 cents, which is why I built it.
Where did you see the design for that?
On the internet. Yeah, it's on the internet somewhere.
Sorry, what's it called again?
A quadrifilar.
Quadrifilar.
Right. They can be longer and thinner, and they have different characteristics and things.
And you mount it that way?
That way up.
Radiates that way?
It radiates
or everywhere?
in a hemisphere.
Oh, right.
Okay.
Yeah.
Now, if we've got a bit of time, I've never tried this.
Is that actual size for 70 centimetres?
Yeah, that's it, yeah. Now, it does have a bit of gain. It's about 2 dB gain, I think.
And what's the impedance for that one?
It's about 50, yeah.
Okay.
It depends on... that one's moved a little bit. You can see there's a bit of a gain to get it right. But took me quite a long time to make that. I actually made that during one of my times when I was shielding recently.
You could also get quite a lot of fat.
Let's just see.
Is the coax feeding both ends, are there? Does the coax sort of supply?
Yeah, it does. It goes in here. You'd have to come and see it really, but it feeds. These 3 wires are fed in parallel from the outer, and then the coax feeds up to here with the outer connected to those other 3. And in the top where the inner goes and drives those 2, and the outer drives yeah, drives that, and of course the other half is the screen of the coax. And it's wanting to make.
Sorry, the name again?
Quadrifilar.
Oh, quadrophilia.
Right, so well, QFA, you often see it marked as quadrifilar antenna. QFA. Quebec Foxtrot Alpha. I'm going to do this.
You seen one of those before?
Yeah,
Okay.
If I transmit this on, change the transmitter to 70 cents, I need a stiff drink to do it.
You sure it's homemade, isn't it?
And I could use the detector because it won't be the right dimensions, but it'll probably pick something up. I can use one of these. That's why every time we get this lot out, it takes us a day or two to
Get some solder with a bit of lead in it.
yeah, it needs some of that. Right. If I can perhaps put this on. That will go on there. No, I know what I can do.
Do you want someone to hold it up or in a certain place or something?
Oh, yeah,
We've got staff here.
work, but
Yeah, hundreds of them.
let's see if we can bring it over the end. Oh. Stepping on the coax is not advisable. As is stepping on the rope when you're climbing. I'm being told off for that as well. From there to there. That one. And I need to reconfigure the transmitter to sounds. So this is totally unscripted.
Don't have to retune the detector.
You'll need to change the connector, won't you, on the rig?
Oh yes,
Steve?
of course, thank you. Just going to sit on there. Otherwise it won't be back in again. Dum. Right. Right, well, that's 432. Right. Oh, need to go to effect.
Yeah, got a signal.
Oh, good. Oh, that's a good start.
On that meter, whether you're supposed to or not, I'm not sure.
I would think so. I would hope so. Graham,
Yeah, it's all right.
He's hiding.
He's hiding.
He's hiding. Okay, I know what I can do. Put the same button on. Oh, that's a lot.
Yeah.
Oh, wow.
Oh, blimey.
That works.
Looks, it does, doesn't it? So,
See where it's just there.
Here on this ridge. power set's on 7%. This is certainly not 10 watts.
So there you can see we're circular there. Come down to the side. We're
No
circular
change
off
in the
side.
meter.
There's no. And this side as well.
It's the same all the way, isn't it?
Yeah, it's the same all the way around. And of course, I'm getting a good pickup even at this distance.
Yeah.
It is actually, it's counterintuitive, but it does work.
Yeah.
Right. Put that button. Oh dear. Right. Oh well.
Yeah.
I thought we were going to the next one.
We're going to be on the receiver transmit to the satellite.
I really can't demonstrate this one. Yes.
It says it's a satellite.
Oops. This is a 5/8 wave vertical. Yeah, it's got about 868 megs, a license 3868 megband. So I can't get that onto anything near the frequency. But the principle of this is that normally a quarter wave wire is about 35 ohms. But if you extend the wire, it becomes, there's a point where you can, there's a feed point here, looks like 50 ohms in series with a capacitor. So if you then cancel out the 50 ohms, the capacitance with the inductor, couldn't find places where to tell you what to do. You then get a 50 ohm feed point, and you get some gain. It also works with 7/8. I suppose it would work with 9/8 if you if you wanted to. 7/8 has even more gain because it brings the load down. The load down. So that's that worked pretty well, didn't it? We were working on a project which had some 868 control on it. Right.
Now, I got a car aerial at home that was quite long for 2 meters with a big coil on.
Yeah.
I never knew whether that was something to do with the inductance or a spring so that when you go under load things.
Well, actually, yeah, I suppose it's a dual thing. I don't think
Yeah,
that
but
would work
it was
like
there
that.
presumably as an inductance to keep the
Yeah. Yes.
value
I think
right.
most of us had 7/8 widths in those days, in the fold over thing, with a gutter mount. But I bought one off of Dave, which was an 8/8,
It was, yeah.
and that was even longer, wasn't
It
it?
was, yeah.
I've never seen one of those, Dave. But
No.
You're too young. Should have seen what people used on top band in the good old days.
Actually, this one is cut for a little bit less than 868 because I've got some of this tubing that slides over it to protect it, and that brings the resonance down a bit. So that was pure trial and error, that bit.
Well, what you need is a VNA.
We got one.
Yeah.
We got one somewhere.
Well, hook it onto the antenna then on a reasonable earth and sweep it and see what you get from it.
DQ2S. What was it? The one
Oh, John, he's got one of your VNAs, yeah.
Which one is it?
DG8 SAQ.
Oh, right, yeah, there's a Q in it somewhere. Yeah.
But nowadays the nano VNA is extremely popular.
Yes. I do have one of those as well.
Well, some people have 2 or 3 because the first ones they bought from the wrong suppliers and there was a big variation in quality.
I think I got my mind from the right place.
Okay.
Right. Right, I think pretty much. I think
Well,
that's...
Shall I have a quick interrupt?
yeah, of course you can.
One thing that you can prove with these antennas is radiation angle. Something that's very important on VHF. So you have to get a bigger tower, Dave. You need about 150 feet.
All neighbours will love that.
Yeah. And then you probably get out reasonably well on 6 metres. You put the antenna on top of it.
Yes.
So one thing that is critical with all of these antennas when above ground is that depending on the height above ground, the radiation angle changes. And Stephen's made quite a study of this, radiation angles and how you enter a duct. And this is very applicable to VHF operation. When you,
if you've got a reasonably good duct, if you've got a duct, the thickness of the duct is important. That limits the frequency that will propagate through it in the same way as a waveguide works like that. It is basically a waveguide. So, the strength of the duct will give you the range of angles at which you'll be able to go into the duct and trap and then go. But what you do tend to find is that because the variation in refractive index is 1.0001 levels in the changes in the refractive index, you have to be very, very shallow angle in order to get in. And unless the duct's really strong, it's about 1/4 degree. So you want to try and arrange for your antenna at VHF to be, the front lobe to be as horizontal as possible. There's no point firing up there. It won't get into the duct, it just goes like that. And unless you're trying to work the ISS or something, it won't do any good at all. Once you're into one of these ducts, of course, you can go thousands of miles.
How do you find them? Are they marked duct?
Enter here.
You can download. Off the upper air radio sons data. If you can get it, there is a US site where you can get it from, and I think strictly speaking, if you're going to use it for anything, you need to get their permission, but it is there, and it's in the weather format, so it's all lots TTAA and TTBB and lots of funny numbers.
Yeah.
But it is known how to decode those. In fact, what you really want is a very old VHF manual, one of the first ones. There's a very good description of it. And I have done it, and I've downloaded things from across Europe, and then you can see where, you can work out where the height of the layer is, and its thickness.
Yeah.
That thing will give you the maximum, minimum propagating frequency. It happens more at 70 sounds than it does at 2. When you get up to things like 23 cents, you get some other effects where you can get scatter modes. Nothing to do with ducting, but there are, well, it is sort of to do with ducting, because there are small variations of refractive index in the atmosphere going on all the time, just little things, and you can scatter off these, either forward scatter, which means you're going like that off the atmosphere, or back scatter where you can come back again. If you hear one of these signals, it sounds quite wobbly, doesn't it? So you get sort of sound, because you're bouncing on lots of different things. So you need quite a lot of power.
Yes. The people that use it do use real power.
And but I think if you engineer it properly, you can get a pretty consistent link. Another thing is that when you get up to the microwaves as well, you can reflect off thunderstorms, because you've got a lot of upwelling, downwelling, and what's going on in a thunderstorm, and you can get a very sharp refractive index change there.
Yes, we've seen that frequently on field day.
Yeah.
When we had a heavy rainstorm, and managed to get coverage of lots of the parts of the country that you fought for the last 20 hours for to try and contact, and they all pop out just like that. Oh, worked him.
Don't mind it leaving on the contest now then.
The other thing about ducting is that it's caused by falling layers in the atmosphere which compress the atmosphere. So it usually happens during a high coming over the country, and the layers, or they compress, they heat up, the bicycle pump effect, adiabatic compression, and that forms these layers. It doesn't happen in low pressure, because in low pressure the air is going up, and anything that forms just goes whoosh, you never see it again.
And is that the effect you can see, like if you look across Bath or Bristol, when they've had long high pressures and you can see it sort of hanging? That's
Now, in the olden days,
Los Angeles airport.
in the olden days, you could usually see a layer of smoke, and then smoke would stop when you got coal fires.
Yeah.
I remember seeing it in Bangor. Lived above one of those layers once, and walking down into the town, you could see it go through.
What about thermals when you've got nice sunny weather and you get thermals with a lovely little cloud on the top? Those columns of air, do they operate in a similar way, or are they pointing the wrong way?
Not that I know.
No.
Not that I don't know either way about that, I'm afraid. The other thing you can do at these sort of frequencies is plane bands. And there are programs that sort of tell you that. Because where we live, just off the end of the runway at Heathrow, you do hear a lot of flutter on signals very frequently.
I got a feeling, didn't we have a presentation about that at some stage? What we do?
But I think there are even some modes, digital modes that designed to work for it. But don't really know about that. I've never tried it.
All I remember was the Concorde effect.
Yeah.
If you were talking into the microphone, you had to say to the guy at the other end, "Don't come back for a moment, we can't hear any bloody thing."
You're 5 and 9, but we did a contest, a 2-meter contest, I think one's from Uri's G4AUC as he was then, and he's even closer to Heathrow. In fact, you see the end of the runway. And we were doing that, and suddenly Concorde took off 11 o'clock in the morning.
We used to occasionally hear sonic booms as it came up the Bristol Channel and slowed down.
Well, he didn't do those over Berkshire, unfortunately.
In the early 80s, I was living in Western-super-Mare. And you could hear the Concorde go supersonic, the double bang as it over the Irish Sea.
Yeah.
Or no, or right the Atlantic side.
The Atlantic fibre.
Yeah.
No,
That's all parked up, rusting down. Shame.
It's indoors now.
Is it?
Yeah, in Bristol.
any other questions, I think?
Everybody's dumbfounded.
That's great.
Well, I can honestly say thank you to both of you, because I think seeing it done and seeing the effect, you can read all the books you like, and because they're on paper, it doesn't show up very well, does it? And seeing it done like this is, well, it's fantastic for me. I don't know what the rest of you
That's
think.
exactly what the other people have said.
Well, yeah, so seeing is believing. And thank you very much, and thank you for bringing all this kit all the way down.
All the way from Bracknell.
All the way from Bracknell. That's real good effort, and let's show our appreciation.
And thanks to David Roy for the dinner as well.
It's been lovely to see you both, because when I was first licensed in 1977, I joined the Bracknell Radio Club, and Graham, in fact, the Bracknell Radio Club introduced me to contesting, VHF contesting.
No, you have a lot of
So you got lots of answer for that. And when we used to go out for a contest, and we'd get all the aerials up, and well, in fact, we have everything set up apart from the coax, because we were always waiting for the Graham to turn up with a roll of pink RG 214.
I've still got it. It's a bit tattered. Yeah, it was double screen.
Yeah.
Thank you
And nothing's changed because we were late tonight. Because
I thought you were late because you made them do the washing up.
it wasn't the coax, though.
Still, it's good go out, silver plated, you know.
We had a friend, G4AUC, who was an installation engineer for the fill-in transmitters in those days, you know, around the Highlands and so on, and he provided us with a few useful bits of spare coax, and that paint stuff came from that source.
Spool ends.
Yeah.
So you guys at Bracknell, you still do a fair bit of contesting, don't you?
Not as much as we used to.
Not so much portable. We're all getting a bit old and decrepit. And lifting 2.5 kilowatt generators out of cars and trailers. and things.
4 kilowatt one.
And it's getting a bit beyond us now. But,
QRP contest, there's your answer.
oh, well,
Done it all from a PP3.
even then you're getting
Wow, the 2 metre low power, yeah, for a PP3. Yeah.
But we have got a lot of new members now, coming in from the foundation and intermediate licenses.
How do you find as a club, what sort of interests have you got? I mean, a lot of our people are interested in DMR, which I don't think is amateur radio, but that's because I'm an awkward old subject.
Is that like FTA, which isn't amateur radio as well?
There's mixed opinions on this one.
I think you'd better moderate this.
Get at it. Develop some interest.
It's my job.
Chief Stirrer.
Chief Stirrer, yeah.
We have a wide range of interests here.
I've got to be a bit careful here because my last job before I took early retirement was as Braycoll's representative on the Tetra Association. So I was involved with.
And you've got a PA, Tetra PA, haven't you?
I have,
yeah.
I used to have to do the compliancy statements.
I think as far as membership is concerned, we're more interested now in young people who aren't bothered about operating, who've got lots of strength, lots of enthusiasm, and lots of spare time in the evening and weekends. So we can drag them along, carry all the stuff, do all the setup, and we'll just wander in and do the operating.
Yeah.
Oh, we should be so lucky.
We did have people like that, didn't we, Ron?
Yeah.
Anyway, yes, we used to do our own foundation courses. But these days, we do our foundation and intermediate courses in conjunction with the Bath online distance learning. And we're finding that works very well. And if anybody wants any tutoring or anything, then we've got some very keen people on the moment, haven't we?
Yes. Yeah.
Anybody here on 80 metres AM? No. One of our members is
Mad on that, I don't know. Honestly.
He has rebuilt a KW Vanguard. He gave a talk and he'd done a good job, and he had to change most of all the capacitors and a lot of the resistors and things, because they'd gone changed all the valve bases because they've been stored without any valves plugged in them, so the valve bases have all got corroded and things, but it's working now. So
I think I tried 2 meters AM once upon a time. Let's get.
Oh yeah, I used to do that.
11 metres, yeah.
That's how we started. Well, I got my G8 call in 1968. I was still at school. And about 1969, Graham got his licence, and I was in Yeovil and in Weston-super-Mare. And we used to work each other quite a lot, didn't we?
Well, we've done it both from Yeovil to Bracknell. And, well, it was easy from Weston, spitting distance. You could see where he lived, just right across the Somerset Plain, you know.
Yeah. I was on a high bit, and you were on another one.
Yeah.
But we've known each other for a lot longer than we've physically known each other, if you like. We both, both joined the Bracknell Amateur Radio, so I know you.
That's good. Well, thank you very much.
Good show. Thanks very much, guys.
Cheers.